our book, Chapter 10, Lesson 6, page 568. Today, we will solve 2 pages from our book. First page is Chapter 10, Lesson 7, page 574. Later, we will solve Chapter 10, Lesson 8.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn about another important geometry quantity called volume. Specifically, we're going to learn what volume is and what kind of units we use to measure volume and how we can calculate the volumes of a few simple geometric shapes. The first thing you need to know is that volume is a quantity that all three-dimensional objects have. But to understand what it means, it will help if we back up just a little and start out with a one-dimensional object, like this line segment. To measure a one-dimensional object, we need a one-dimensional quantity, which we usually call length. The length of this line happens to be exactly 1 centimeter, which is a common unit for measuring length. And in the Math Antics video about area, we saw that if we move or extend this one-dimensional line in a direction perpendicular to it by a distance of 1 centimeter, it forms a two-dimensional object called a square. Two-dimensional objects are measured by the two-dimensional quantity that we call area. Because the original line was 1 centimeter long, and we extended it a distance of 1 centimeter, the amount of area that this square occupies is 1 square centimeter, which is a common unit for measuring area. Okay, now imagine that we take that two-dimensional square and move or extend it in a direction perpendicular to its surface by a distance of 1 centimeter. It forms a three-dimensional object that's called a cube. And to measure a three-dimensional object like this, we use a three-dimensional quantity called volume. Volume tells us how much three-dimensional space, or 3D space, an object occupies. Alright, but how much volume does this cube have? Well, since it was made by extending 1 square centimeter, a distance of 1 centimeter in the third dimension, we say that its volume is exactly 1 cubic centimeter, which is a common unit for measuring volume. So square units are used to measure area, and cubic units are used to measure volume. Since square units are made by multiplying two one-dimensional units together, like centimeter times centimeter, we can abbreviate them using the exponent notation, centimeters to the second power, or centimeters squared. And since cubic units are made by multiplying 3 one-dimensional units together, like centimeter times centimeter times centimeter, we can abbreviate them using exponent notation, centimeters to the third power, or centimeters cubed. And just like there were different sizes of square units, like square inches, square meters, or square miles, there's also different sized cubic units, like cubic inches, cubic meters, or cubic miles. See how area and square units are related to volume and cubic units? And there's another similarity too. Do you remember how you can use square units to measure the area of any 2D shape, not just squares? Well, you can use cubic units to measure the volume of any 3D shape, not just cubes. To see how that works, take a look at this 2D circle and this 3D object called a sphere, which is like a ball. Just like you can use a bunch of small squares to approximate the area of the circle, you can use a bunch of small cubes to approximate the volume of the sphere. And here's the really cool part. The smaller the squares you use, the closer their combined area will match the area of the circle. And the smaller the cubes you use, the closer their combined volume will match the volume of the sphere. Okay, so volume is a 3D quantity for measuring 3D objects. But since we've also talked a lot about area in this video, I want to point out that 3D objects also have a type of area that you don't want to confuse with volume. You might remember from our previous videos that 2D shapes have both a 2D quantity called area and a 1D quantity called perimeter. Well, in a similar way, 3D objects have both a 3D quantity called volume and a 2D quantity called surface area. Surface area is a lot like it sounds. It's the area of the object's outer surface or shell. Perimeter and surface area are both outer boundaries of geometric shapes. Perimeter is the one-dimensional outer boundary of a two-dimensional shape, and surface area is the two-dimensional outer boundary of a three-dimensional shape. And to help you see the difference between surface area and volume, imagine that you have a perfectly thin box filled with ice. If you unfold the box, you can see the 2D area that surrounds the volume, while the volume itself is the amount of 3D space occupied by the ice inside the box. Alright, so now that you understand what volume is, and you won't confuse it with surface area, we're going to spend the rest of the video learning how to calculate the volumes of some basic geometric shapes. But before we do that, I want to quickly mention something important about terminology, or the words we use to describe things in math. Most of the time, people agree on what to call things in math, but not always. And that's especially true when it comes to the words that we use to describe the dimensions of geometric objects. Take the words length, width, and height, for example. If I have a rectangle, I can name its two dimensions length and width, like we did in the area video. But I could also name them width and height if I wanted to. The actual names of the dimensions really aren't important, so different teachers might use different names. The important thing is to be flexible and realize that the math concepts are the same, even if different words are used to explain them. For example, the area of a rectangle is always found by multiplying its two side dimensions together, no matter what they're called. Okay, back to calculating volumes. A lot of 3D shapes can be formed by taking a 2D shape and then extending it along the third dimension. For example, if you start with a rectangle and then extend it along the third dimension, you get a 3D shape called a rectangular prism. If you start with a triangle and then extend it along the third dimension, you get a 3D shape called a triangular prism. And if you start with a circle and extend it along the third dimension, you get a 3D shape called a cylinder. From the others, you might have thought that it should be called a circular prism. But technically, prisms are shapes that are formed by extending a polygon. And since a circle is not a polygon, the resulting shape is not called a prism. Okay, so the good news is that there's a general formula for calculating the volume of these types of 3D shapes. All you have to do is find the area of the original 2D shape that got extended and then multiply that by the length or distance that it was extended. Usually, that original shape is called the base of the object. So, let's start with this rectangular prism and calculate its volume. The base is the original rectangle, and its dimensions are 4 centimeters by 3 centimeters. So to find the area of that base, we need to remember how to calculate the area of a rectangle. To do that, we just multiply the two side dimensions together. 4 centimeters times 3 centimeters gives us 12 centimeters squared as the area. Now, to find the volume, we just need to multiply that area by the length that the base was extended. Our diagram tells us that distance is 10 centimeters. So if we multiply 12 centimeters squared by 10 centimeters, we get 120 centimeters cubed. So this rectangular prism has a volume of 120 cubic centimeters. Okay, let's try to find the volume of the triangular prism now. Again, the first step is to calculate the area of the base of the prism, which is the triangle. The formula for finding the area of a triangle is 1/2 of the triangle's base times its height. Be careful not to confuse the base of the triangle with the base of the prism, which is the triangle itself. Our diagram tells us that the base of the triangle is 10 inches and its height is 8 inches. So 1/2 the base times the height would be 1/2 of 10 times 8. 10 times 8 is 80, and 1/2 of 80 is 40, so the area of the triangle is 40 inches squared. Now all we have to do to find the volume is to multiply that area by the length that it was extended. We're told that the length is 50 inches, so we multiply 40 inches squared by 50 inches and we get 2,000 inches cubed. That's the volume of this prism. All right, are you ready to try finding the volume of the cylinder now? The cylinder is made by extending a circle, so first we need to calculate the area of that circle. As we learned in a previous video, the area of a circle is found by multiplying pi times its radius squared. The radius of this circle is 2 meters. So if we square that, we get 4 meters squared. Then we multiply by pi, which is approximately 3.14, and we get 12.56 meters squared. Now that we know the area of the circle, to find the volume of the cylinder, we just multiply that area by the length that the circle was extended, which happens to be 10 meters. 10 meters times 12.56 meters squared gives us 125.6 meters cubed. So the volume of this cylinder is 125.6 cubic meters. So, do you see how to find the volume of 3D shapes like these? Shapes that are made by taking a 2D shape and then extending it along a third axis? You just find the area of that shape and then you multiply it by the length that it was extended, and that gives you the volume. And it works for any 2D shape. It works for trapezoids or pentagons or diamonds or stars or hearts. All right, man. Now that I know how to accurately calculate volumes, playtime is way more fun.
Our first question here, I need to find the volume for the figure. Okay, What is our formula for the volume? V equals area of base multiplies height of the prism. Area of base multiplies height of the prism. Okay, how we can find the area of the base? What is the base here? The base here is rectangle. The base here is rectangle. Okay, so if I have rectangle, what is the area of a rectangle? Area of rectangles is width multiplies length. So 9 multiplies 9 equals 81. Now we go back for our volume. Volume will equals area of base. We find here area of base here. Okay, equals 81. We find here area of base 81. So we will take it, okay, and multiplies by the height. What is the height here? The height here is 2 centimeters. So 81 multiplies 2, it will equals 162 centimeter cube. Don't forget to put the unit. So in the area here, we have to put the units. Unit is a square. And here, what is the unit for the volume? Cubed. Excellent. Let's go next question. Question 2. I need to find the volume for this cube. First, what's our formula? Our formula is volume equals area of base multiplies height of the prism. Area of base multiplies height of the prism. What is the area of the base here? Area of base will equals length multiplies width. So 4 multiplies 4 equals 16 inches square. And so we will take the 16 for the area of the base, okay, and put it for the volume. So 16 is the area. Volume equals area multiplies height. We have here the area of the base is 16 and the height here is 4. So we have 16 multiplies 4 equals 64. Don't forget the units. In area, what is the unit on area? Square. What is the unit of the volume? Cubed. Excellent. Let's go for next question. Question 3. I want to find the volume here for this prism. What's our formula? Volume equals area of base multiplies height. Area of base multiplies height. What is the area of the base here? Area of the base here equals 2 multiplies 5. Okay, 2 multiplies 5 is 10 feet square. Then I will take the area of the base and multiply it with the height of the prism. Height of prism here is 1. So I will take 10 multiplies 1. I will take this 10 for the base and multiplies for the 1 if the height. So it will be 10 feet. What is the unit of the area? Unit of the area is a square and unit of the volume is cubed. Question 4. I want to find the volume for this prism. What is the volume of this prism? We have here our formula is volume equals area of base multiplies height. Area of base multiplies height. What is the kind of the base here? Kind of base here is triangle. Can you see? It's a triangle. Okay. So what is the area of triangle we took before? What is the area of triangle? So area of base is triangle will equals, what is the area of triangle? Half base multiplies height. How many bases we have here in the shape? We have a lot of bases. For this triangle here, can you see it? We have base 9 and we have height 6. Okay, for this triangle we have base 9 and height 6. Okay, how we can use this? So here it will be half multiplies base of triangle is 9. Base of triangles multiplies height of triangles, and this is with the small letters to be different from the volume with capital letters. Okay, so area of triangle or area of the base, and the base here is triangle, So area of the triangle is half base multiplies height for triangle, not for the prism. We have half multiplies 9 multiplies 6. This will equals 27 meter square. Okay, and then we will take this base and multiplies with this height, so we will have the volume. Volume will equals 27 multiplies 13. 13 is the height, 27 is the area, 13 is the height. So 27 multiplied 13 will be 351. What is the unit here and what is the unit here? We have the unit here is a square and here cubed. Check. Question 5. Question 6 first. Okay. Question 6 here we have, what is the base here? The base here is triangle. So it's a triangular prism. What is the area of triangle? To find the volume of the prism, we need to find the area of the base. The base is triangle, so we need to find the area of triangle. So our formula is volume equals area of base multiplies height of the prism. Area of base multiplies height of the prism. Okay, take the area of the base. Area of the base, what is the area of the base here? The base here is triangle. So triangle means, what is the area of triangle? Half base multiplies height. What is the base of triangle? This is the base of triangle, 25 decimeter. And what is the height of triangles? 10 decimeter. So we will take 25 half first, and 25 multiplies 10. So half 10 is 5. 5 multiplies 25. This will equals 125. Okay, decimeter square. Don't forget the unit. Then we will take the area here and the height of the prism and multiplies together to give us the volume. So the volume will equal the area of the base multiplies the height of the prism. This will equals for us 2500 decimeter cubed. Cubed because it's a volume. Okay. Question 5. You have here also triangular prism. You have prism. The base of the prism is triangle. So let's do the same. We have volume of any volume of prism is area of base multiplies height. Area of base multiplies height. What is the base here? The base here is triangle. What is the area of triangle? Area of triangle is half base multiplies height. But here the base and the height is for the triangle. Where is the base and height for triangles? We have 8 and we have 4. So half 8 multiplies 4. Half 8 is 4 multiplies 4, so it equals 16 feet square. And what is the volume here? The volume, I will take the area of the base multiplies the height of the prism. It will be 16 multiplies 20 feet will equal 320 feet cubed. Don't forget the unit. Now it's come time to solve our book for chapter 10, lesson 8, page 578. Let's start solve our second part from our lessons. Let's check our first question here. We need to find the volume of this cylinder. We have height of cylinder 15 and radius of the circle here is 4 meters. Okay, so what is our rule? Volume of cylinder will equals area of base multiplies height. Area of base multiplies height. So let's find area of base. Area of base here what? What is the base? The base is circle. So what is the rule of the circle? Pi r square. We took it before in last session. So area of base will equals pi r square. Pi equals 3 and r is 4, so I will take 4, this 4, and multiplies by itself, and pi equals 3. So 3 multiplies 4 equal 48 meters square. Then volume will equals area of base 48 multiplies height. So this one is the area of base now B, and 15 is the height, so I will put it here. So 48 multiplies 15 will equal 754 meter cubed. Don't forget the unit, cubed. Question 2. I have this cylinder. I need to find the volume of cylinder. We have here r equals 2.5. We have height here is 8. Okay, let's put our rule. Volume of cylinder equals pH. What is pH? P is area of base multiplies height. Area of base multiplies height. What is the base here? Base here is circle. So let's find the area of the circle. Area of circle is pi r square. Pi equals 3, r equals 2.5. So let's put 3 multiplies 2.5 multiplies 2.5. This will equals 18.75 centimeters square. Now go back to our rule here. Okay, we have volume of cylinder will equals area of base multiplies height. What is the area of the base here? 18.75, and the height is 8. So 18.75 multiplies 8 will equals 150 centimeter cubed. Why I put cubed? Because it's a volume. Question 3. I have here cylinder. Let's find the volume of cylinder. We have here circle with radius of 10 inch and we have height of 10 inch. So here we have volume of cylinder equals area of base multiplies height. What is the area of the base here? Area of base here, or B, will equal pi r square. Why pi r square? Because the base is cylinder. So area of base equals pi r square. Pi equals 3, r equals 10. Square means that I will multiply 10 by 10. So 3 multiplies 10 multiplies 10 will equals inch square. Now let's find the volume. Volume will equals B. Now 300 multiplies height is 10. So it equals 3000 inch cubed. Don't forget the unit, inch cubed. I have these two shapes. I need to find the volume of both of them and then find which one is the biggest one. Which one has the biggest volume? Okay. By looking at the pictures, can you tell me A or B will be the biggest volume? This is tall but thin. This is short but fat. Okay, so which one will take biggest volume? Let's see. Question A or picture A. Cylinder A. I have here diameter of 4, height of 15. Okay, what is our volume? Our volume is area of base multiplies height. What is the rule of the base? Pi r square. So I need r. I have diameter and I need radius. So r will be 4. This 4 is diameter. Here I took it and divided by 2. So it will be 2 feet. Okay, let's put it here. So B will equal 3 multiplies 2 multiplies 2. 3 is by 2. Here is the radius, and I will multiply the radius by radius will be 2 by 2. 4 multiplies 3 equals 12 feet square. So the volume here is 12 multiplies the height is 15. Okay, so 12 multiplies 15 equals 180 feet cubed. This is cylinder A. Cylinder B, the fat one. I have here radius of 5 feet and height of 10. Let's put our rule. Volume of cylinder equals area of base multiplies height. Area of base, what is the base? The base is circle. So let's find the area of circle. It's pi r square. Pi equals 3. And r here is 5 feet. So 5 multiplies 3 equals 75 feet square. Now volume will be B, that's equals 75, multiplies 10, the height. Okay, multiplies 10, the height. So this will equal 75 feet cubed. Don't forget the unit. So now, which volume is biggest one? This one is 700 feet cubed and this one is 180 feet cubed. So which one is the big? B is the biggest volume. Our homework is page 578 from question 8 to question 13. Also, we have homework in page 574 from question 8 to question 13. Join me on Zoom session next week.